All right, class. In this video, we begin our discussion in section 4.4 in your textbook on the laws of logarithms. So we're going to be building upon what we learned in the previous section about logarithmic functions, right? How logarithms are just a fancy way of expressing the value of an exponent. The good news is there are only 3 laws of logarithms that you have to know. Way back in section 1.2, excuse me, at the beginning of the semester, we learned about the rules of exponents, and there were several of those. There were several rules of exponents that we learned. In this section, laws of logarithms, there are only 3 rules we have to learn. And so here are the 3 rules. We'll go through them one at a time. The first rule is called the product rule. And it says the log in base A of the product of 2 numbers, A and B. Now, both A and B have to be positive numbers. So the log of that product in base A is equal to the log of the first number in base A plus the log of the second number in base A. The second law, called the quotient rule, says the log of a fraction or quotient, right? The log of A divided by B is equal to the log of the numerator minus the log of the denominator. So A is the numerator, B is the denominator. So the log of A over B is equal to log of the numerator minus the log of the denominator. The third rule is called the power rule. And it says if I have a positive number A raised to a power C, A to the C power, then the log of A to the C power, I can take that exponent C and I can bring it down in front of the logarithm. So log of A to the C is equal to C times the log of the number A. So these same 3 rules, right, apply to the natural logarithm. Remember, the natural logarithm is just a logarithm in base E, right, the number E. So let's demonstrate these 3 laws of logarithms with some examples. So first we're going to demonstrate the product rule. Right? And remember, the product rule says the log of a product of 2 numbers is equal to the log of the first number plus the log of the second number. So we're going to show that the log of 4 times 8 is equal to log of 4 plus the log of 8. And then you notice that the logs are in base 2. The base has to be the same. Can't be different. Well, 4 times 8 is 32. So log base 2 of 32 is equal to 5, right? Because 2 to the 5th power is equal to 32. So log base 2 of 32 is equal to 5. So this sum on the right-hand side also has to equal 5. Well, log base 2 of 4 is equal to 2, because 2 squared is equal to 4. And log base 2 of 8 is equal to 3, because 2 cubed is equal to 8. And so we got 2 plus 3 on the right-hand side, which indeed is equal to 5. So this is a demonstration with real numbers that the product rule works. In the next example, we're going to demonstrate the quotient rule. Okay? So we're going to take the log of 9/27 and show that that's equal to the log of the numerator 9 minus the log of the denominator 27. And we're doing this in base 3. Well, on the left, 9/27 simplifies to 1/3, right? 9 is divisible by 9 once, and 27 is divisible by 9 3 times. So 9/27 is equal to 1/3. Well, log base 3 of 1/3 is equal to -1, because 3 to the minus 1 power is equal to 1/3. So now we've got to show the difference of these 2 logs is also equal to -1. Well, log base 3 of 9 is equal to 2, because 3 squared is equal to 9. And log base 3 of 27 is equal to 3, because 3 cubed is equal to 27. So on the right we have 2 minus 3, which is equal to -1. And so this demonstrates the truthfulness of the quotient rule, right, with real numbers. Lastly, let's demonstrate the power rule. So we're going to take log base 2 of 4 to the 9th power and show that you can indeed take that exponent 9, bring it down from the log, and that's equal to 9 times log base 2 of 4. Well, 4 to the 9th power is equal to 262,144. So log base 2 of 262,144 is equal to 18, because 2 to the 18th power is equal to that same number, 262,144. And so we got to show that this on the right is equal to 18. Well, log base 2 of 4 is equal to 2, because 2 squared is equal to 4, and 9 times 2 is indeed equal to 18. So this demonstrates the validity of the power rule